When trying to estimate some sample mean, we need to know how big our sample size needs to be. So how do we find it? Well, we find it by using this formula here. N equals z sub alpha over 2 times the population standard deviation sigma over the margin of error, and all that is squared. So when you are given sigma and you're trying to find a sample size, this is the formula you need to use. That's your biggest clue. Do not forget, always round your answer up. Always round up if your answer is not a whole number. If it's a whole number, leave it there, but if it's a decimal, you always round up. So let's look at an example. How many daily rainfall amounts in Boston must be randomly selected to estimate the mean daily rainfall amount? We want 99% confidence that the sample mean is within 0.01 inches of the population mean. We also know that the population standard deviation is 0.212 inches. So let's pick out what we know. We know that sigma is 0.212. We know that our margin of error, because it has to be within this right here, 0.01, that's how close we want it to be, so that's our margin of error, 0.01. And now we find our critical value, but to do that we have to find our alpha over 2. So alpha over 2 is going to be 1 minus 0.99, because that's how confident we want to be, divided by 2, and that's going to end up giving us 0.005. So we now need to find our z value, our critical value, 0.005. And nice way we can do that is just using our calculator. So bring up the calculator and we're going to go to second bars and number 3 inverse norm of 0.005. And we're going to do that and we're going to end up getting 2.58. We don't care about the negative, we only want it as a positive number. So 2.58. Now that we have everything we need, we're going to plug it into our formula. So N equals 2.58 times 0.212 all over 0.01, and this is, again, squared. Now we're going to plug it into our calculator to make it easy. So 2.58 times 0.212 divided by 0.01. And I like to just put everything in first, what's inside the brackets or parentheses, and then I square it, just to make sure I don't make an error along the way. And I'm going to get 2991.6. Now, like I said before, if you do not get a whole number, you always round up. So since I did not get a whole number, I got a 0.65 something other, I'm just going to round this up. So N is going to equal 2992. So how many rainfall amounts must be randomly selected? A minimum of 2,992. So let's look at another one. How many adults must be randomly selected to estimate the mean FICO score of working adults in the USA? We want to be 95% confident that the sample mean is within 3 points of the population mean, and we are aware the population standard deviation is 68. So again, let's pick out what we know. Our sigma, our population standard deviation, is 68. Our margin of error, they said within 3 points. So it's not percentage points, it's just 3 points. So we just say the margin of error is 3. And now we got to find our alpha over 2. So alpha over 2 is going to be 1 minus 0.95 divided by 2, which will be 0.025. So we're going to find the critical value corresponding to this. So z sub 0.025. And again, I would like to use a calculator to do the work for me. So that's what I'm going to do. So second vars, number 3, and the area is going to be 0.025. And that's going to give me 1.96 because I don't want the negative. So 1.96. And now that I have everything here, I'm going to plug it into my formula. So n equals 1.96 times 68 over 3. And again, that is all squared. So what does that come out to be? Again, let our calculator do the work for us. So I'm going to do what's inside 1.96 times 68 divided by 3. Hit enter, and then just going to square the whole thing. And it's going to be 1973.7, but because it's a decimal and not a whole number, I'm going to round it up to 1974. So how many adults must be randomly selected to estimate the mean FICO scores of working adults in the U.S.? A minimum of 1,974. Do not forget, you must always round up if you do not get a whole number. I cannot stress it enough. If it's not a whole number, round it up.